Hi, today we will check a warm-up problem on arrays. So the problem is given an array, find the number of elements having at least one element greater than itself. Consider this array. We will consider this array. So find the number of elements having at least one element greater than itself. So we need to check each element in the array and we need to compare with other element, and if it is having any element greater than itself, any one element, at least one element greater than itself, then we need to uh, add it to our result. So we need to find number of elements. So we need to find number of such elements having at least one element greater than itself. So consider this array. We will check by iterating through this array. So first we will consider 1. If it is having any other element greater than itself, we will check other elements. 4 is greater. Yeah, we need to consider 1. We will take 4 now. Is it having any other element greater than itself? So 1 is less than. 7 is greater. Yeah, 4 we need to consider. So we'll take 7 now. Is it having any other element greater than itself? 1 is less, 4 is less, 3 is less, 9 is greater. Yeah, we need to consider 7. Then we will consider 3. Uh, 1 is lesser, 4 is greater. Yeah, we need to consider 3 as well. So now we will consider 9. Is it having any other element greater than itself? 1 is lesser, 4 is lesser, 7 is lesser, 3 is lesser, 0 is lesser. So we don't need to consider that. We will consider 0. Is it having any other greater than? Yeah, 1 is greater than. So we need to consider 0. But we need to return only number of elements. So we need to count how many such elements. So 1, 2, 3, 4, 5. So we need to return 5. So the solution, the first solution come that comes to our mind is iterate through the array, and for each element we need to compare uh, with the other elements in the array, and if any element is greater than itself, then we need to add that in our result, and we need to break, we need to return. So the solution would be, first iterate through the array. Okay, so we need to each element with other element. So for finding other elements, again we need to iterate through the array. So here I will take j as iterating variable. So I am comparing each element with the other elements in the array. So now if a of I is the element which I am comparing, how I am comparing, if a of I is lesser than any other element, so which means some other element is greater than itself. So I am incrementing the result. So initially it would be 0, so I am incrementing, and finally I am returning count. So this is the first solution which will come to our mind. So if you see, this is a brute force algorithm. We are not doing anything. We are just converting the problem statement into code. This direct conversion of this English statement to some pseudocode. So if you find the time complexity of this solution, it will be big of n squared. But we need some optimal solution. So if we observe this array, you will come up with some pattern, or it's not a pattern, we can say an observation. So totally it is having 6 elements and the result is 5. So if you see, the greatest element in the array is 9, its count is 1. So if we find the greatest element in the array, and if we find the number of greatest elements in the array, and if we subtract that count with the total number of elements in the array, we will get the result. So find the number of elements having at least one element greater than itself, which means how many elements won't have element greater than itself. That is the greatest element in the array. So if we find the greatest element and number of greatest element in the array, by subtracting that count with the total number of array, we will get the solution. So for that, we need to find greatest element in the array. Then we need to count this greatest element. Then we need to subtract this count with total number of elements in the array. So this will be the solution. So okay, we will write a pseudocode for this. So for finding the greatest element in the array, first we will consider a max element as minimum element supported by the compiler. So now we will compare each element with the max. So if max is uh, less than a of I, then now max would be a of I. So this way we can find which is the greatest element in the array. So this part is over. Now we need to count this greatest element. So we will consider, we will have this, we will have counter 0. Then again for this also we need to iterate through the array, and we need to compare each element of the array with max. If it matches, then we need to increment this counter variable. So we found out this also. So the third point is we need to return this n minus count. So this will give the number of elements having at least one element greater than itself. So this would be the optimal solution. So if we check, the time complexity will be linear, that is big O of n, and 2 iterations. But there is an even optimal solution that uh, would be having only one iteration. So that would be so finding the greatest element and counting the greatest element in a single loop itself. So how can we do that? So again we will need to iterate. For that also we need to iterate through the element, through the array. And so in this case we will have 3 cases. So if a of I is equal to max, or a of I is less than max, or a of I is equals to max. So 3 cases we are having. Greater than max. So if it is equals to max, so no, first we will consider this. If a of I is less than max, you just need to continue. You don't need to check anything. If a of I is greater than, then it will be max plus plus. will have this count as 0, the count plus plus. So if it is greater than 0, then that time we need to reinitialize this max with a of I, and we need to again reinitialize count with 1. So this will find the maximum value in the array, as well as it will count the number of maximum elements in the array. So now we will return n minus count. So this will be the optimal solution for this problem. It will have only one iteration, and the time complexity will be big O of n.